Hey guys, welcome back to another episode of Simuleo. So today, we are going to be finishing up these simple Huffman trees. If you weren't here yesterday, we did a lot. We got a heck of a lot done, and I'm very happy with what the trees look like now. But there's one thing we have not done that I would like to try to visualize. However, it may or may not work out. So keep that in mind. Today's kind of an experimental day. I would like to go ahead and try to visualize the actual encoding of the each individual letter. Now, this is not the easiest thing to do, and I've thought of a whole bunch of different schemes to try, but I have one that I want to try in particular, and that is going back through each tree that we create, going through each, I guess, line, and showing how it creates the bitmap is what we called it, but basically the map of which letter means what character, and then we can kind of go from there. Hey Gustrun, so let's go ahead and get started, as always, by opening up Zernal and talking about what Huffman encoding is and where we intend to go with this. So, first things first, as of right now, we have the ability to visualize Huffman trees, and again, I think they look pretty good. One second. I couldn't find my pen. Hey, Mr. Sutherland. So, the idea is pretty simple. Huffman trees. Okay, so here's the idea. The idea is if we have some sort of frequency of all the letters coming into our system. So let's say we have, I don't know, A with 70%, B with, I don't know, 0.15%, C with 0.10%, and D with 0.05%. Sorry about that. Then we add these guys together to make 15. 1 second. These guys together to make 0.3. These guys together to make 1. And then we go back through the tree to see how we encode each individual letter. And for the record, how I did this is I went through and I added the two lowest valued at any given point in time. So at this point, the two lowest values are 10 and 5. At this point, they are 15 and 15. Here, they're 70 and 30. So we just kind of added up the two lowest values. We go back through, we add 1, 0, 1, 0, 1, 0. And we go back through and we read. So we say A, reading this way, is 1. B, reading this way, is 0, 1. C, reading this way, is 0, 0, 1. And D is 0, 0, 0. So if we have a phrase of, I don't know, A, B, B, C, D, it's going to be 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0. And that is our phrase. Now, of course, I've mentioned this from the very beginning. There are more complicated ways to do this, but this is what we've got right now, and I'm happy with how far we are at. So, like I said a few minutes ago, we now want to actually visualize this encoding process. So, how do I intend to do that? Well, page, new page before. In our visualization scheme, we're visualizing the other way around. So we have a root node up here, and then we have all of our individual nodes coming off of these guys here. Okay? So if I wanted to go through and say, hey, what is A, B, C, D? We'd go through and we'd say, okay, well, A is going to be 0, 0. So 0, 0. B is going to be 0, 1. So 0, 1. C is going to be 1, 0. Let's see, 1, 0. And D is going to be 1, 1. There you go. That is our encoding phrase. And I want to do something quite similar here. So basically, we have our tree already created. Now I want to go back through and visualize that encoding method. And that's because it's not obvious when you see the tree how to read it immediately. So if we just have some sort of visual indicator of how you're supposed to go back through and do the encoding, that's fine. The other thing too is, though this isn't essential, I think it'll help a little bit in one of my explanations when I'm doing my video and trying to describe what Huffman trees are. So we might end up not really using it, but I think it's important just to try, because if we can get something that looks really good for the visualization of the encoding, that's really, really good. That's what we want to see. And if it doesn't look that good, it's okay. We did our best. And that's kind of where we're at right now. So The reason we're not moving straight onto the vidder algorithm is because, first of all, I wanted to give this a try, and second of all, honestly, I'm having a lot of trouble. I have like, here's one of my many pages with trees that I'm drawing based on the vidder algorithm, and I'm trying to figure out how it works. I can't quite get it to work out the way I want it to. So I haven't quite figured it out. We're almost there though. I can feel it. It's like, you know, right there in front of me. I just can't get to that last step of it. So we're getting there with the vidder algorithm, which is the adaptive Huffman encoding method. What I might do tomorrow, guys, I realize it's like 5 in the morning, but what I might do tomorrow is I might go through and finish up one last simulation I have to do for my determinant video that's coming up on Sunday. Yeah, this upcoming Sunday. Because this last visualization hasn't been done yet, I'm kind of stalling with the determinant video stuff. And honestly, I have to spend time this afternoon finishing up the video audio recording for it, because this weekend I'm not going to be able to do it. This weekend I have to work on stuff for an OIST skill pill, where we kind of teach people basics of random stuff. So because I have to work on that this weekend, I don't have time to do my video editing, so I have to do it over the week, which means I have less time to focus on the stream stuff. Basically, long story short, I think tomorrow we'll take a step off from the Huffman encoding stuff, do one more determinant visualization video, and then we'll come back to Huffman encoding after that. Again, I apologize for hopping back and forth so much, but again, I'm very happy that we're taking our time with the Huffman encoding stuff, because had I needed to do a video on Huffman encoding this weekend, I feel like we wouldn't quite be there yet. So I'm happy with how far we've gotten. Okay, so let's see what we need to do next. Right now we have some code. This code is generating a tree. The tree looks pretty good. So let's go into CD projects, Simuleos, and Huffman. Let's go over here. Projects, Simuleos, Huffman. Let me run a quick git diff of what do I want? I want Huffman visualization .cpp. 1 second. Where are we? 353. So let me go into vi Huffman. Actually, if it's only that one change, can I do this? Git reset hard. Then I want to do Huffman visualization .cpp. Cannot do with paths. Oh, never mind. I'm not going to worry about that. Let's just do this. Vi Huffman visualization .cpp. Let's go down to 353. Okay, it looks like it did say 353, didn't it? 1 second. 353 root ori. Okay, let's do this one. Root ori. Let me see. Ori X, I think is what I wanted. No. It wasn't ori at all. Wait, what? Root wait. Oh, it's in the grow circle command. Of course. What am I doing? Let's just go down here. Go to where the grow circle command is. Draw tree, grow circle. Here it is. And I want to multiply this by 0.5. Okay. Right, quit. Now let's go over here and let's run make. Give it a second to make the animation, and I'll show you what the animation looks like right now. Again, I think it looks pretty good. With the different color schemes and everything that we added yesterday, I really think it looks top-notch, you know? Then what we can do is describe what I want to do from this point in order to show the encoding method once we have the animation up. Give it a second. For some reason, I don't know. Okay, so let's go here. Let's do Mirage. I think it's just the last Mirage I used. I wasn't able to use this computer very much yesterday. Yes, okay, so this is what we've got. Let me get a quick sip of water. Also, my voice was going yesterday, and I don't know what happened to it. Okay, so what are we showing here? Let's go ahead and go through one step at a time. So the first thing we're showing is a visualization of each of these nodes. The nodes are located based on where they're at in the tree. So what we did is we went through first, figured out what the tree needed to be, and then we did the visualization of each individual external node by doing a very quick depth first traversal of the tree. Then what we did is we changed the size of each individual leaf depending on the weight. So the bigger the weight, as in the more times it's used in our encoding phrase, the bigger the orb. And then we also changed the color based on the weight. So it goes from green to yellow to red, depending on how, depending on how much it weighs, how much stuff, how many times we've used that image, or that word, letter. How many times we've used that letter. Okay, then what we're showing here is also the Huffman encoding. So as you can see, and let's scroll down real quick. So we show the visualization of each of the individual letters. Here we are. Then we show the encoding, where we add the two lows together, two lows together, two lows together, two lows together, two lows together. We always add the two lows together continually. So you'll see that it goes layer by layer. And we keep doing that until they're all added together and we have our final Huffman tree. And that's the idea. Now what are we going to do now? Well, now let's take this image and let's see if we can just manipulate it a little bit. So what I'm going to do is I'm going to open up GIMP, image frames, sorry about that, image 00200, I think it's 199. Yeah, .png. Okay, so here's our image that we have so far. Actually, let's change the way that we're visualizing this. Let's go up here. Let's move down here. Okay. So you'll note a couple of different things. One, we are using up basically the entire y-axis. That's fine. We have to think of a way to not use up the entire y-axis, but that's fine. That'll come in a bit. So tools, Windows, recently closed box, toolbox. There we are. Okay. So here's what we're going to do. I'm going to pick out a color. The color is going to be somewhere in blue. Why not? Something like this. How about that? Okay. So here's what I want to do. To visualize the encoding, I was thinking of something like this. Let's scroll in a little bit. The color... Oh, oops. I just realized that would do that. So let's see. Let's scroll down a little bit here. Maybe 5, I would guess. I'm not sure. 1 second. 5. Okay. Yeah, that should work. Okay, so we're going to click here. And then we'll go here. There. 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 And then we'll say, okay, so we're reading the first branch, right? And then we'll go back and we'll say, okay, to there. Reading the second branch. And then we'll go to here, there, there. Reading the third branch. Reading the fourth branch. Reading, so on and so forth. So I was thinking about just going through like this and reading each individual branch so that you can kind of see what's happening. So this is what we're trying to do, except in code. And the reason we want to do this way is so that we can show people, have some sort of visual indicator of what they're supposed to do to get the encoding from this tree. So then we go all the way back here, up here, so on and so forth. So the idea isn't so bad. We basically do the same depth, we do the traversal that we did before, except in this case, we also go through and highlight each of these individual boxes. And this will kind of give us a number. And I want to put the number or the string that we're encoding into kind of under each of these guys, because all of these guys have a distinct X location. We should just be able to kind of drop down the string that they're being encoded into underneath it. So we'll see how it looks. I think it'll look pretty good, but I'm not quite confident yet. I have to actually see it to see how it goes. So let's go ahead and discard changes. And again, guys, this might be something that we end up throwing away at the end, but I think it really does have a place. So let's go ahead and modify Huffman visualization to go one step at a time. So first of all, I'm adding 100 frames. Okay, that seems pretty good. Now, what do we need to do? We need to create a new function, which is, let's go down here, draw encoding. So let's go here. 1 second. Function to visualize. And while this is running, I'm just going to run Raj, just so we have what we currently have up on the screen. So if anyone has any questions, they can ask it, and we can answer those questions as they come along. One last thing to point out. Actually, let me check my stream real quick. Okay, that's fine. I was afraid that no one was here or that there was something wrong with my stream because, again, chat was a little bit quiet. But that's okay. It's only been 15 minutes, so what was I expecting? Okay, function to visualize the encoding process. Wait, what? Oh, shoot. Let me scroll up. That was me being an idiot. Visualize the encoding process. For you Europeans, I'm sorry, I have English spelling. Visualize is spelled with a Z. My bad. Okay, so now we're going to say void. I'm going to call it draw encoding, even though that doesn't make very much sense. I guess it should be animate encoding. However, I did everything else as draw, so it's okay. So draw encoding. We need frame, animation. Then what do we need? We need node star root. And I think that's all we're going to need here. Let me go through and let me think. Is this it? Yeah, I think each of the individual nodes should have an XY location. So I think this should be good. I think. Let's see. Int level, node queue, regenerated nodes, in alphabet size. Okay. So let me think. Yeah, this should be good. So we have our draw line command. We have everything we need. So let's just do it. So draw encoding. Let's go down to the bottom. Oops, sorry about that. Let's go down to the bottom. Let's do function to draw encoding scheme. And then we're going to say void draw encoding. And again, guys, if you have any questions, comments, concerns, let me know and I'll totally talk about that as soon as I see it in chat. Frame, anim, anim, and node star root. Okay. Now, we're probably going to see that we need more as we go through, but for now, this is all I think we need. So what we need to do is start at each individual location for each node and basically go through and do the drawing, right? So we need a very quick recursive algorithm to go through and do the drawing. So we have the draw tree command, but this kind of does it a little bit differently. So maybe there's a way. Now, let's just create a new traversal function. So, let's see, draw encoding. What we could do, oops, I did the same thing I did before. What we could do is actually have this draw encoding be the, let me think, be the recursive function. Okay, so we've done depth first search before. Depth first search is what we'll be using again for this. Here's our draw tree command. Basically, let's just copy this for now, and then we'll modify it for what we need it. Let's go down here, and let's go here. So, we don't need any of this this stuff here. None of this is necessary. Basically, we go through and we say if there's a left, if there is a left node, we go to the left node, or right node, sorry. If there's a left node, we go to the left node. And then if there isn't a left or right node, we kind of don't do anything. So let me see. Or rather, we do something special. So root or ex. Okay. So this is kind of the idea. And of course, we can perform operations on our standard node whenever necessary. So what do we need? We need a couple different locations. Now let me see. Do I keep the parent node? That's the question. I think I do. But even if I didn't, I don't think it's that important. So what we're going to do is at every individual node, we are going to draw a line to the right node. And then we're going to draw a line to the left node. And then, let me think, so we're going to draw a line to the right node, then to the left node. Yeah, that should work. And if we're drawing a line to the left node, we're going to erase the line that's drawing to the right node. I think. Yeah, that should probably work. Okay, which means this is going to be a super easy thing to do. Let's go through here. And let's see what we need to do. So first of all, we need draw encoding, which is going to have frame animation. So we're going to want anim. Then we want root pointing to right. Down here, we're going to have draw encoding. And we want enum, root, pointing to right. Okay. So what are we going to do next? Next, we have to basically draw our lines. So where's our draw line command? Animate line. Here it is. Do we give it a color? Animate frame. We do not give this guy a color, which is a little unfortunate, which means we have to draw them all white. So let's go through and let's change that a little bit. So animate line. Let's add in a color. CLR. And let's make sure we have a color struct. We should. Yes, we do. Let me go ahead and put this over into Huffman.h. So Huffman visualization.cpp. Copy this guy. vi Huffman.h. And let's put it right here. Struct for colors. Right quit. Huffman visualization.cpp. Okay, now let's go through and see what we need to do. So I'm going to go through and see if I used color anyway. Color. Colored. Fair enough. Next. Colored. Color ramp. Okay. I am an idiot and have not used color throughout this. I've had a color struct this entire time and I haven't used it. My bad. Okay, so let's go through and let's modify this. So every time we see animate line, let's go through and add in a color. Animate line. There's animate line, of course. Let me go to the very top and let's search. Animate line there, animate line there, animate line here. Okay, so this is in draw internal, which I guess would obviously be the only time in which we would draw the line. So let's go down here and let's create a color. So in fact, we can probably create the color up here. Let's see, if temp node key. Yes, okay. So we can probably just create the color up here so we don't constantly create it in the while loop. So let's do color. Line color. Then we're going to say color. Line color dot r is going to be equal to 1. Line color dot blue is going to be equal to 1. Line color dot green going to be equal to 1. Then we go in here and we read in the color. So let's go down here and add in line color. And go down here and add in line color too. Let's see. I guess I'm going to have to put it on the next line. Line color. That's a very long call, but hey, that's how it goes. Okay, so animate line. I think these are the only times we're going to be using animate line at this point. So let me go down to the bottom, make sure that this will, yes, it should run. Let's write this, go over here, and let's make it. I just realized I screwed something up. Yeah, let me go up to animate line one more time. I forgot in the animate line function itself to add in, oh no, I have the color. Oh, good. Okay, so let's go down here and change this to color.red, color.blue, color.green. Red, color.blue, and of course, color.green. Okay, RG. Oh gosh, it's RGB, not RBG. I did this before too. GB. Right, this, now let's make it one more time. Give it a second to do its thing, and then we'll see if we have the same animation. We should. We didn't really change very much, but that's okay. Taking it one step at a time, making sure we have everything. Oh, this time we have 300 images because I, for some reason, decided to have 300 images. Oh, this will be an interesting test. Oh. Sorry for the yawn, guys. Man, I don't know. I've been getting very little sleep lately because of X, Y, and Z. Hey, I care. What's up? And it's kind of sort of getting to me right now. Not so badly. I mean, but you can probably tell I'm a little bit out. Not that much out, but a little bit out, maybe. I don't know. Okay, good. So, two things are successful. One, the line colors are white. Yay. Second, the animation stays for all 300 frames, which for some reason I wasn't confident it would do, but that's okay. Perfectly okay. So now we have to animate the line. I'm going to take this guy and I'm going to copy this and bring it down here. Put it down here. Okay. Oh, my bad. What do we need for animate line? Okay. We need frame anim. Good, we have that. We have start frame. Sure. In a way, we have that. We have double time. We have that. Position 1, position 2. Good, we have everything we need. Absolutely fantastic. So, start frame. What's start frame going to be? It's going to be anim.currentframe. You don't look like your usually animated self today. Sorry about that, Mr. Miyagi. As I just said, I'm incredibly exhausted, but that's perfectly okay. Let me go back through and see what we did for animate line. For the previous 2 animate lines. Animate line. What do we have here? Animate line. Animate line. What did I say for time? I said time divided by number of lines. Great. So what did I read in for lines? I read in draw internal, double time. Let's go up to that. Double time. Draw internal. Oh my gosh. Draw internal. Here we go. You know how, like, I don't know if you guys have this problem or not. If you guys code in the morning, you'll totally know what I mean. But there is a time when you're super tired and you try to put in inputs with your fingers and, like, it's delayed just a little bit for some reason and you can't seem to... Yeah, that's like every moment right now. I don't know what the deal is, but that's okay. Perfectly okay. So, draw internal. I gave it 10 seconds to draw this entire guy. We have how many lines? Let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 24 nodes. I just made up a number, 25 nodes. Then we have, I don't know, we're going to have to add those together. So 24 plus 12 plus 6 plus 3, let me think. 24 plus 12 is going to give us 36. Plus 6 is going to give us 42, plus 3 is going to give us 45, plus 1 is going to give us 46 total lines. So 10 seconds divided by 46 means we have how many seconds per line? That's going to be, how many seconds per line? I have no idea. 46, 10 seconds. Let's say it's 50 lines to draw. 10 divided by 50 is going to give us, 10 divided by 5 is going to give us 2. So I guess that would be 0.2 seconds. Okay, fair enough. So we give everyone a quarter of a second to draw. Down here. So this is going to be 0.25. 0.25. Good. That was quick math. If you have questions on how I did it, feel free to ask in chat. Okay, so position Ori 1, position Ori 2. These are the 2 locations that we're at. So it's going to be root.position. Pointing to position. Wait, what did I call it? I think I just called it Ori. Ori. And then we do the next origin, which is going to be down here. 1 second. Why do I keep the comma? Funny how you're working on trees today. Today I'm working on... cool. And tomorrow, a star. It might not make it out alive. Good luck. Honestly, a lot of those algorithms I have not implemented before. As much as I'd like to implement them at some point, I need to kind of go one step at a time. I'm still super slow with this kind of stuff, as I'm sure most of you guys know. And of course, because I don't have an official computer science background, it ends up being that I don't really need to implement these things until all of a sudden it comes up in research. In which case, I will find a paper, I'll read it, I will implement it then. That's typically what happens. Okay, so now we do the following. We want root, pointing to right, pointing to Ori. Then we do color, where in this case, we're going to read in the following. So we're going to say color. Oh, actually, we can set the color up here. So we're going to say color is going to be equal to, let's say color blue. 1 second. It evolved so much. Yeah, it looks pretty good. Hey, Zivo. B-L-U-E. Okay. So now we're going to say color blue. Color blue. Dot red is going to equal 0.25. Then we want, sorry about that. Color blue dot green is going to be equal to 0.25. Then we do color blue dot blue. It's going to be equal to 1.0. Okay, so what we're doing here, I don't want it super blue. I want it like kind of light blue. Does that make sense? Maybe not. Okay. When we were doing our subroutine webcomic stuff a few weeks ago, I found that there are a whole bunch of colors we can use, some of which that look better than others. And in order to make a blue more light blue, we just have to add a little bit of red and green to it because that makes it more white, right? So this is kind of what I wanted to try. We might want to mix the color around a little bit, but for now this is fine. So now we also want color white. Oh, what was I doing? That's not how you create a variable. Color white. Now we're going to do the same thing we just did. So it's going to be color white dot r is going to be equal to 1.0. Color white dot green is going to be equal to 1.0. And then of course we do color white dot red, blue. Oh gosh. This is a B. Is going to be equal to 1.0. Okay, so now we have our blue and our white color. So we're going to go down here and we're going to call it color blue. Okay. Now we do the same thing over here. Draw encoding. Let's do. Oh, we have draw encoding. Good. And we're going to change this to root left. And then we're going to draw the line too here. So let's go here, animate line. And basically copy this exact thing because it's not really going to change except for this root right origin is going to change to root left origin. So we're going to change that. Left. Okay, let's write this. Now, I've got a couple of other things to do before we can actually animate this. But let's go ahead and give it a shot. Let's go to the top. And then let's go down to, 1 second. Where are we? Main. Here we are. Okay, where does main end? Main ends here. Okay, so we have draw internal, and it looks like none of these guys really manipulate the original tree that we get from Huffman tree. So let me see just to make sure. Final tree, regenerate nodes. Let me go up here just to make sure. So let me see, root, node star root. Good, so we still have the same tree that we had after the 2-pass Huffman. So let's go down here, and guys, the two-pass Huffman is what we did here to do the encoding, right? So the idea behind Huffman encoding is that you have to have some sort of frequency of how often a character appears in order to do the Huffman encoding, right? So what we do first is a 2-pass algorithm, go through and check how frequently the letters appear, and then we do the encoding. So that's kind of what we're doing here. We're showing the frequency at which they appear, and then we're doing the encoding after that. Again, guys, if you got any questions, let me know in the chat, and I will totally answer those questions as soon as I see them. Okay, so next we need to do the following, which is going to be you know, I just oh, layer 2, we can do that. Hey, I love Twitch, what's up? So now we're gonna do draw encoding. And what do we want? We want layer 2. And then we want Huffman tree. Right? The colors look great. What do we want? We want, I think, one more thing, which is Huffman tree. What is it? Final tree, I think? No. Yeah, final tree dot root, I think. No, tree? Oh, what did I call it? Final tree dot root was right. Okay, so let's go ahead and write this, and let's see what it looks like. So we're gonna do make. It's gonna break. Good. Okay. Let me go and fix this. So 416. We have void animate line anim. Doesn't like anim for some reason. Animate line declared void. Oh, that's because it doesn't. It likes anim. I just called this thing void. I wouldn't like being called void either, just for the record. If someone called me void, man, they would get in trouble. My mom would just, she'd do something. Tattletale. Okay, so color blue, anim, good. Let's write this, go over here and make. And let's see what we got. Color white says it's not used, which is fair enough. It's not currently used. Okay, so it's making all 300 frames, and let's see what it looks like at the animation. Again, I've got a feeling it's gonna look silly. All right, so forgive me with that one, because, yeah. Okay, So give it a second to make the animation, and then we'll take a look at this again. What we should see now is a bunch of blue lines going from the root node back down to each individual node. And then we have to do the hard part, which is visualizing the actual encoding. And that's going to take some time. So what do we want here? Let's go ahead and take a look at the animation. Here we have all the dots appearing. Great. All the lines coming up. Great. And we have each of these lines being created, which I think looks pretty good. You know? Yeah. Okay. What do you guys think about the blue here? I think it looks okay. So now we have to do one more thing. Animate line does this. And let's go from there. So I think we can make the blue a little bit more blue. So let's go here. Let's change this to like a little bit of a lighter blue. So let's change it to 0.5 here. 0.5 here. Let's run that one more time after fixing one last thing, which is every time we go left, what I want to do is not keep the color that way. So what I want to do is I want to change the color back to what it was before. So let's see. Good. So let's see. I want to do the following. I don't want to animate the line. And actually, let's make these guys go a little bit faster too. Instead of 0.25, let's make them go at 0.10. Just because these lines are taking a little while to draw. Then what do we want to do? Let's go through and do the following. So we're going to say we want to draw a line that is white from one location to another location. So let me go to animate line and let's see what we got. So where's animate line? Somewhere up here. Draw internal, animate line. Here we are. So all we did before was we gave it 2 origins and we said Cairo line 2 here to there. So we do the same thing. Cairo line 2, except this time we changed the color. So let's go here. I'm just going to take all of this. Take that whole guy. Bring him down here to the bottom. Copy this. Copy that. Put that there. DD. And let's copy this line. Bring it down to the bottom. Oh, oops, I did that one wrong. 1 second. I'll get back to you in a second. Here we go. Okay, so let's delete this line. Let's delete these 2 lines. Okay, first thing we need to do is set everything to the appropriate RGB value, which in this case is going to be white. Color white, white, and white. Okay. So I'm going to bring these guys down to the next line just for clarity's sake. Next, frame context. We don't need that. We just need anim. Oh, wait. We do need frame context. Okay, that's fine. Next, we say Cairo line 2, animation.frame context. Fair enough. I feel like I'm doing something wrong here. Oh, this should be animation.current frame. Yeah, that's what I want. So all these eyes are going to be changing to animation.current frame. 1 second. E. And this is going to be changed to animation.current frame. And I just realized one more thing. How about this? How about we do this another way? Let me do the following. Let me just animate the line. The same way we just did, except using color white and going in the opposite direction. Just to see what this looks like. It might not look good. That's fine. We'll just see what it looks like. So it's going to be root left, pointing to origin, and then root origin. Change it to color white. 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 And I just realized this is going to be white. Right. Oh gosh, this is really hard to say. Right. Good. Okay, let's see what this looks like. Right, this, go over here, run the make command. Make command, not ache command. And let's see what happens. So we're generating all the images, all 300 of them. And now let's see what the blue line looks like as it goes through. I'm thinking this will look okay. And the worst that happens is we just don't animate the encoding in the end. If it doesn't look good, it doesn't look good. You know, that's how it goes. You guys are going to have to let me know what you think. If you guys like the animation, let me know. If you dislike the animation, let me know. Again, I'm not very good with this whole art thing. And so this is kind of not the easiest thing for me to really see. Is this visually compelling? Does this tell the story? That's what we need to do. This animation needs to tell a story of how to draw a Huffman tree and how to read from a Huffman tree. So, we're on to animation.gif. Okay, we're drawing all the dots. That's absolutely fantastic. Creating all the lines. Now, we're going through. Oh, I screwed something up. Yep, totally screwed something up. So, let's go through and fix that one up. So, the new blue is a little bit too blue, or too white. So, let's go through and change this to 0.4. I think it might be hard for you guys to see. Let's change it back to 0.3. And let's change this one to 0.3. Okay, let's make the line take a little bit longer to draw because that was, yeah, let's make it take a little bit longer to draw. Well, maybe this is fine. We'll see. Okay, so animate line color blue. Oh, okay, so one last thing I need to do up here is change the left branch to, let me think. Animate line. Oh, I see what I need to do. The following. So here, if we get to the left branch, let's animate one more line, which is going to be another white line, except this one going the opposite direction. So let's take this, animate this, go from the root origin to the root left origin. Right, this, go over here, and let's do another make. I hope I wrote it. I think I did. Oh, what's the worst that could happen? If I didn't write it, I didn't write it. Too bad. Okay. Give it a second. I think I just screwed up again. Yeah, I'm pretty sure I just screwed up again. Yep. Yep, totally did. Shoot. You'll see how I screwed up in just a second. Yep. Yeah, that's wrong. That's okay. Okay, so we're going to give this guy a second to run. Let's go over here. Mirage animation.gif. Okay, so as we watch this, you should be able to see blue lines be created. And these blue lines are going to go through. Yeah. Yeah, that's what I thought was going to happen. Okay, so how am I going to fix this? Let's take this line. And let's just put it up here. And let's do the following. Let's remove these lines here. Okay, so what this is saying is every time we draw a line to the right, we are clearing a line to the left. Yes, that should work, I think. Yeah, we'll see. What's the worst that could happen? Let's write this. I don't think it's quite the line to the left. I think I screwed something else up. So let's make it one more time. And let's see what we're actually drawing here. Good. On the upside, it's a beautiful day on this lovely island of Okinawa. I can see clouds, I can see the ocean. It's great. It's just a great day. Okay. Again, let me know if you have any questions. Chat's been kind of slow today, so I can only presume that means that there are no questions. But if you have one, let me know. Again, it doesn't necessarily have to be about Huffman encoding. You guys can discuss absolutely anything you want. Could be, I don't know, life, liberty, and the pursuit of Huffman trees. Oh shoot, that has to do with Huffman trees. Okay, so we're gonna draw this, see what we got. 1 second. Good, 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 good. Yeah, I screwed up. Okay, so let me think here. What do we actually need to clear? Let me go through and let's see. So what I want to do is the following. I want to, let me think. Close this. Oh, I wanted that open. Let me scroll down a little bit. Okay, so here are all the lines being created. Now, here are all of them being drawn. We need to clear. Okay, so here we draw our first left line. We go up, and we go down. So the line that we actually need to clear is root left right origin. So let's try that. So it's going to be root, animate line. Oh, if there is a left-right origin. Oh, wow. That's interesting. Okay, so how are we going to do this? Let's do this. If root pointing to left. Oh, that was an equals. Pointing to left. Pointing to right. That was a dot. Okay, there we go. We do the following. And let's go ahead and add a couple spaces here. So, 1 second, dot. Okay, so we do left. Let's see, it's going to be, let me see. Okay, so it's going to be, we're here, left. So it's going to be root, let me see, root left origin. And it's going to be left, right. Okay, let's see if this does it. So again, the problem here is that as we're going through the tree, let's scroll down here. We leave a whole bunch of blue lines. And this is fine, not a big deal. In fact, I don't even know if we want to clear the lines afterwards, but for now, let's go ahead and clear it, and we could actually keep the tree blue. In fact, here, let me try something. What do you guys like better? Let's go ahead and draw this one that stays white, and then we're going to draw the next one, which stays blue, and I want to see what you guys think. If you guys like it to stay white, let me know. If you like it to change blue after the encoding, we can do that too. Totally up to you guys. I have no real preference here. So let's see what we got. Give it a second. We have to put it into a graphics interchange format file. I'm currently doing something in Node.js, Vue.js, and SQL. So I listen to you in the background. That's fine, not a problem. I had time with Node.js, but I'm finally starting to understand it. Had a hard time. It's kind of hard. So let's do Mirage frames animation.gif. I too am having a hard time understanding Node. I'm still wrapping my head around callbacks and promises. You guys are better than I am. I screwed up. Dang it. I hate when I screw up. Of course, it happens literally every day. Let me see. So we are at root right. This is before drawing the right line. We are drawing the right line from root origin to root right origin. Okay. If root left right. Okay, 1 second. Let's scroll down. Draw all these lines. Okay, so we're drawing all the right ones. We're drawing a left one. Now we have to clear the left one. So it's gonna be root. No, we have to clear the right. Clear the right one is the one we need to clear. Wait a minute, I'm a little confused here. Are these drawn correctly? Did I mix up my right and left? 1 second. So here we are clearing root right origin. I think this is reversed. I think we're drawing right first and then left, when it should be left first then right. Let me go to where we're drawing the 1 second, draw a tree. Where is it? Draw a tree. Frame init, let me see. Grow circle, animate line, draw internal, regenerate nodes, draw tree. Here we are. We're going right first. We're clearly going left first. Yeah, that's clearly left. Yep. Yeah, that's a left. Let me go down here. We're saying we're going right first. Huh. Why is it going left then? It doesn't really matter. It's fine either way. It's just interesting. So oh, this needs to be an A. 1 second. Cairo set source. 4. Let's just go ahead and quit this. Open it up down here. Okay, so that's fine. However, let's see, root left origin. Does that mean this has to be root? Wait. We go left one, right one. So I guess this would be right one, left one? Alright, this is what I get. Left. Right, this go over here. Let's do make. Oh, oops. I should probably go up here. Huffman visualization failed. Segmentation fault. The heck? Let's comment this out. Oh, I know why it's a segmentation fault. Right, left. Right, left. Make. Give it a second, and we'll see what happens. Yes, good. We got all the frames being created. Fantastic. Let's see what's happening. Let's see. I too am having a hard time understanding node. Gust Nest, what are you having trouble with? Good. Okay. So, let's see what we got here. We're going to draw the animation. It's going to look like crap, but that's okay. You know, that's the story of my life. Don't read into that too deeply. Okay, so what are we going to do? We're going to watch it break in just a second. Promise it's coming. You know, suspense. Mirage animation.gif. Okay, here we have all of everything being created. We have all the lines being created, and yes, so we still have this line being drawn. Again, all I'm trying to do here is remove this left line, right? So I need to get rid of that left line. I did this before. One second. I did this before by simply redrawing over the right line, which is fine. Let me see something. Animate line, animate line, animate line, root right, left. Let's see, what are we doing? We're drawing a line from root right origin to, yeah, so I'm clearly mixing up my right and left, which is fine. I just need to know that. So let's scroll down. Okay, so I need to clear, yes, I need to clear this line. So how about when I do the, let me think. When I draw right, oh, wait a minute. Scroll down a little bit. Okay, here. This is different. Here we go. Okay. So, the issue here is I have to clear this line, this line, this line, this line, and that line. Okay. I'm now starting to see the problem. Okay. So what do we need to do? We need to draw encoding. This is actually a little bit more complicated than I thought. So here's the way I was currently doing it. We were going through drawing all these blue lines, and then as we were drawing all of these blue lines, I wanted to clear the blue lines that, let me think. The blue lines that we didn't need anymore. So, for example, we would only have, one second, the one necessary line. So this line right here being drawn to the node. So we draw, you know, this to that, right? I didn't want all of these extra nodes being created over here, or all of these extra lines being created. At this point, what I've currently written is not going to work. So here, let me just go ahead and delete all of this because that's all going to be wrong. And delete this guy here. And the reason it's not going to work is simple. I am missing a whole bunch of lines. So let's go ahead and write this. Let's go over here and let's make this. So this is going to give us a blue tree. The blue tree is okay. I think it may even be better this way because that way we can say, you know, we have done the encoding with this tree. So the blue tree would mean, hey, look, the encoding has already been completed. For now, let's move on. We'll come back to the blueness of the tree later. We can try to color it white. In fact, we could color white in a number of different ways. What if we do, let me think, draw encoding. Yeah, what if we read the color into draw encoding? In that case, we could color it blue, and then go through and color it white, without very much trouble at all. So let's do Mirage frame animation.gif. And this is again going to create a blue tree in the end. So here's all of our stuff. And you'll see what I mean by blue tree in a second. So there you go, blue tree. I don't know how it looks from a distance. It might look okay. In fact, here, let me just do this. Scroll down, change it to blue, scroll back. I think it still looks good, guys. I mean, I think it looks pretty good. But that's just me. Of course, I'm going to say it looks good because that way I have to do less work, right? So, okay. So the next thing we need to do is we need to create a function to draw. Are you going to do something? One second. So next we need to draw a function or make a function to write out the binary code for each individual digit. So what does that mean? What do we need? We need stuff. 1 second, I'm thinking about what we need. We need text to drop down at each of these letters. Oh, sorry for the yawn, guys. I'm super yawny today. Okay. Okay, so what are we going to do? Let's create that function. What's the function going to be called? We're going to say function to drop. I was having trouble writing code to kick off a trivia game. Let's see, Mr. Miyagi. When I was making my own Twitch bot, I was having trouble writing the code to kick off a trivia game. I think I'm still confused about MVC and how to call code in other JavaScript files. Maybe I need more experience with JS. Unfortunately, I don't know. I'm sorry about that. Okay, so we're going to say function to drop text under leaf node. So what is it going to be called? Void drop text. That's a test. Text. Okay, so we're going to drop the text. And that was a void. I need a void. Okay, come on. I can type today. Drop text. So what do we need? We need a couple of different things. We could read in the Huffman tree. That's something we need. Huffman tree. Definitely need that because that's going to have our bitmap in it. What else do we need? We need a location of the node. So let's do position Ori. Is that all we need? And time. Let me see. So double time. I think that's it. I can't think of anything else we'd need. So let's take this and copy this up top. Drop down to main. Pop up a little bit. There. Drop text. Okay. Go down to the bottom. And let's do it. So what do we need to do? Basically, we just need to draw text downward. Now, writing text is not the easiest thing to do in Cairo. I will totally admit that. And while I admit that, I'm going to get a quick sip of water. 1 second. Man, I always get so thirsty when I'm doing this dang streaming thing. But I guess that's good. I guess it's good. Better than yesterday where my voice just kept dropping out at random. Oh, there it goes again. Okay. Good. Okay. So, Huffman tree, position Ori, double time. We have the position of each of the individual objects. That's X and Y position. Both are important here. Good. Okay, so we've already done this whole text thing once in this code. So let me see. Text. That was test. Text. Placing text in circle. Cairo text extends T. Okay, let me just take this. And let's see what we got down here. Paste it in. I'm going to remove a couple lines. And let's see what we need to do. So let's do, I don't know. It looks like X8. 1, 2, 3. Oh, I guess that's because I need to do this. I think it's 8X. Yeah, that's what I want to do. Okay, good. For the record, what I just did is I pressed the letter 8 and then the X key. In VI and Vim, if you press a number and then a letter, such as D or something like that, it will perform the action, assuming it's a simple action, over 8 or so times, however many times you press. So if you press a button, like let's say 9, and you press X, you can delete X characters or 9 characters. Okay, so we're going to set the source, RGB. In this case, I set it to black, but I actually want to set it to white. Okay, next we say Cairo text extends text box. Cairo text extends frame animation test. Splines, Gusthorn, if he has problems with understanding the concept workflow of MVC, I doubt ES6 is really solving that problem. Honestly, guys, I have no idea, but I'm glad you guys are having discussion in chat. That is useful. So text extends T, text box. Wait, what? Test? What am I doing? Let me go up really quick. And let me see, what do we have here? Splicing. What is test defined as? Char test. Oh. Oh, I see. I see. Okay. Okay. Yeah, I can dig it. Okay. So what do we need to do? Let's go through down here. Let's see. We're reading in Huffman tree. But what we should do instead is read in the encoded phrase, or rather, std string. And what do I want? What should I call it? I don't know. Code word. Yep. Sticking with the same notation I used before, which was definitely not code word, but that's okay. Up to the top, down to main. And let's change this to std string code word. Because guess what? Naming conventions. Okay, so what do we need to do now? Well, we need to figure out a couple of different things. So let's go through and say for int I equals 0. That was an I. I less than code word dot size. Then we do plus I. Pop this down here, go over here, and do the following. Now, let's go ahead and set number. Add in a couple spaces from 436 to 445. What do we want? S. There we go. Set no number. Good. Now, what do we need to do next? Now we actually just need to draw everything. So for I and codeword.size, basically what we need to do here is we need to place them all into the appropriate X location, where the X location is going to be under the under each individual letter. So we're going to assume that we have the letter itself, and then we go from there. So let's see what we need to do. So Cairo text extends. This is telling how big our text is. So what we want is code word at, that was code word, completely different meaning, word at I dot C string. And I think that should work. If it doesn't work, sorry. Okay, so we have our text box. Now Cairo move to, we have to move to the appropriate location. And then we have to show the text at that location. What is the appropriate location? Well, in this case, what we used before was root ori x. That's not quite right in this case. So what we're going to have to do is ori.x, since we're reading in the origin, ori.x, and ori.y, subtracting the textbox.width divided by 2.0. That's fine too. However, we also in y need to subtract out an additional location. So we're going to subtract out, I guess it's going to be I, let's say double of I, times, then we want the text width. Now, the size here, I think the size, if I'm not mistaken, is 15. Okay, so let's just pretend it's 15 for now, and now we're going to write out code word I.cstring. Now, one last thing we need to do here, show text code word I.cstring. Okay, so one more thing we need to do is every time we see a J here, we need to change the J to something else. So it's going to be, yeah, it's going to be this. And this is kind of a cheapo way to do it, but that's okay. Since we want them all to be drawn with the same, at basically the same speed, here's what we're going to do. We're going to say this. J is going to be equal to animation dot current frame. Are we reading in that? Ah, dang it, we're not. Current frame plus I. Okay, there we go. That's all we need to do. Then at the end, we're going to say, how about we do J equals animation current frame? And then we go down here and we say animation dot current frame plus equals 1. There we go. Super simple. we're done. And we have to read in one more thing in here, which is frame anim. Good. Now we don't need double time. This was a design decision by me, but that's okay. So we're going to see if this works. And then after checking to see if it works, we will then, go back through and comment this. We have to make sure it's commented because, quite frankly, it's not the easiest code to understand. So let's go up to the top. Main, drop text. Oh gosh, what am I doing? DD. There we go. Now we go down here, root left, and we're going to do the following. We're going to say if there's a root right, if there's a root left. Now what we want is one final one that says if there is no root right, pointing to right, and there is no root left, we then drop text. So let's go down here and say drop text. So drop text. And we're going to need frame animation. So we want anim. Then we want code word, which we can find and position Ori. So this is going to be tree.bitmap. I think this might be wrong. Anyway, let's do root pointing to key. And then we want root pointing to origin. Okay, so we have to read in one more thing, which is in draw encoding the Huffman tree. In fact, we could just read in the bitmap. That might be a little bit easier. So let's do, oh, maybe it won't be easier. 1 second, let me think. Let me figure out what the Huffman tree is. So let's go right quit, vi Huffman.h, go down to the bottom, and we should have a Huffman tree somewhere in here. Huffman tree gives us an ordered map of character double. We want character string, this guy. So we'll just take in the bitmap. So let's write and quit. Huffman visualization.cbp down to the bottom, up to the function call where all of the arguments are, and add in that bitmap. Now pop it down here. Good. Okay, so now draw encoding should be basically done. Let's go up and fix up the wait. Now it should basically be done. Okay, so now draw encoding. Let's go and fix up the call at the very top. And draw encoding. Draw encoding. Here we are. Let's remove this and add in this and a semicolon at the end for good measure. Okay. Make. Give it a second to do the mayo. Never mind. Give it a second to break. Final tree.root. 132. Draw encoding. Of course. Of course. .bitmap. Make. Okay, what else broke? J was not declared in the scope. Fair enough. Hey, Witty Bants. So, 442. Oops. 442. Let's go here and let's say int J. Next, what's the problem? 445. Error request for C string in code word. Yeah, I figured this would happen. Dang. Okay, error, expected semicolon. Good, 453. That one I might be able to fix. Okay. So, the problem here is, of course, the same problem we had before, which was converting every individual letter into, how do I put this? Into something that Cairo likes, which is a C string. Now, C strings apparently I always have trouble with. I don't know about you guys, but every single time I have to deal with them, I have trouble with. So this is what we did before. We created a character test, and we went from there. I'm going to do the same thing, because I'm cheap. So let's go here, and we're going to do the following. That. Char test root key, except in this case, it's not going to be root key. This guy should be code word of I. Now, instead of using code word of I, let's change all of these guys to test. Good. Where's the next code word of I? I believe it's just here. And then we go from there. So this is just test. Write this, go over here. Let's try making it one more time. Okay, root right, root left. Let me see, what do we have here? 424. Could not convert root node right from, yep, fair enough. Let's go to 424. We just need to read in bitmap. And down here, read in bitmap. And finally, let's change this to a size t instead of an integer. And I think this should be okay. We aren't using color white. That's fine. Let's see what the frames look like. And then we'll take a look at the encoding afterwards. Give it a second. It'll take just a little while, more than a second. It's, you know, as mentioned yesterday, it's probably closer to 15. I don't know. We'll see. Taking our time. Anybody play Pokemon Go? I can't play Pokemon Go because it's not out in Japan. But, you know, it's kind of ironic, I guess, in a way. It's not out in Japan. Oh, there's someone running outside. Hey, person. Oh, here we are. Good. Now we go to mirageanimation.gif, and let's see what we got. Here's all of the dots being created. Let's see what happens when the tree turns blue. Oh, well, that's super interesting. Not at all what I anticipated. Yep, that's... Yep. All right. Cool. It's kind of swept the nation in a way. Okay. Well, this wasn't what I expected. Yep. Good. Okay, so in case you guys aren't watching, I don't know when it's coming out in Japan. Every time we go down to the node, we are drawing a number at the appropriate time. However, the numbers are going in the wrong direction, and they're also just popping upwards and then disappearing forever. I know why that's happening. It's something we need to fix. So let me go back up to the animation, and we'll fix it from there. Hey, the Mad Dave, what's up? So let's bring it down over here, and good. Okay. So how are we going to fix this? Well, we're going to fix this the only way that we can, which is in the following way. So what do? Draw layers here. What we need to do is Cairo show text animation current frame. This for int j equals animation current frame, j less the number of frames plus j. That's what we need to do. So we need this additional loop here. Basically, all we're doing is we are drawing the number to each individual frame, because right now we're only drawing the number to a few frames at a time. So let's do that for int j. Let's take this, and now you guys are probably going to see how short-sighted I am, and that's okay. That's perfectly okay. So let's go down here, and let me see, what do we need to do? So first things we need to do, it's going to be animation current frame. Where am I using I? I'm using I to find what character we're writing, okay? So let me think. We're going to go through each of the number of frames. For size t, I less than codeword.size. This is where things are actually a little bit challenging. So let me think. At this point, we at the current frame that we're currently at. What are we doing? So instead of going through codeword.size, let me think. We want to go through. No, this is right. We want j inside of I. So let's go here, put in that j. Okay, good. Now let's mess with this again. Animation.current frame, char test is equal to code word of I. Let's define that out here. Right there. Remove it in here. Remove this j equals, and now let's set number. Okay, what do we want? 447 to 456. 447 to 456. We are going to add in a couple of lines. Good. Set no number. Thanks, Zadiston. How are you? Okay, so now we have one more loop that we need to end. So here we're ending that loop. Good. So let's get these numbers drawn. How am I going to do this? By the way, SE string is typically passed by reference to avoid unnecessary copying. Can we do that here? Yeah, we can. I'll do that. Thanks. So let's go here. 1 second. I wasn't thinking, but that's okay. So let's go up to the very top. The lack of syntax highlighting is so brutal. I'm used to Visual Studio. That's fair enough. I mean, it's a situation. I go the opposite way. Like when I see people coding in like IDEs and things, I always have trouble figuring out like where to place my eyes. You know, like with colorless code, I admit it is hard to figure out where to go. Like your eyes just don't naturally flow in the right direction. It's like, you know, if you're going through a PowerPoint presentation and everyone in the everyone just puts up a giant mathematical formula in front of you, it's kind of hard in a way to tell where it is you're supposed to put your eyes, you know, like you don't know what to do. Yeah, that's totally fair, Zadison. I totally agree. I probably just missed it a few times, so we'll see what we do. Okay. Yeah, see, that's the thing. A lot of times IDEs, I can't figure out what to look at, and that's okay. Vector and maps. Yeah, I'll worry about that in a second. Okay, let's go down here. A few times there were a few times that I wanted to pass it in by copying instead of by reference, because I modified it inside of the function itself. There were some weird things there, so I'd have to copy it anyway. But that's okay. I'll look into it in just a second. For now, let's go ahead and finish this up, and then we'll go from there. I realize it's probably bugging you. I apologize. But we'll fix it as soon as we get the rest of this drawn. So we're going through each letter I. And for each letter, we are drawing it in the appropriate location. And then we're going through and putting it in every single frame. So let's go down here, and let's say this. So we're going to say animation.currentFrame. Plus equals 1. Now, is this fair? Let me think. So we go through every I, and in the I we write down, let's say 0 to every single frame. So we grab 0, we create the character test. Then after that, it's no problem whatsoever. Foolish gaming. The way it is, I don't care how you code. All right, like for me, I'm not like I use the I don't even use them. You know, like what I'm using right now is just the most minimalistic setup you could possibly use. Pretty close to it anyway. And I like it, so I'm fine with it. But truth be told, if you're using an IDE, I have no problem with that. Like, we're not creating wars here between, you know, like different IDEs or text editors or anything like that. Point is, we're here coding for the joy of coding. That's about what we're at. The convenience of an IDE is totally worth it, though. Sure, it depends. So I can't use an IDE at work. I have to use Vim or Emacs or something like that. Rather, I could use an IDE, but it's not, I don't know, it feels wrong for me to use an IDE because, again, I'm on someone else's computer. I'm on a cluster. And if I'm on a cluster, I feel like I don't want to be hogging resources with an IDE. But that's just me. So what are we doing from now? Okay, we're going through Kairosaurus RGB. We're setting it to white. We're going through giving it an appropriate location, which is fair enough. Then what do we do? After that, we give it an appropriate Y location. Text box double of I. Yes, so I think, unless I'm completely incorrect here, this is going to have to be a plus still, but this is going to have to be another plus. Because again, the reason the numbers are going up instead of down is because Cairo reads the other way around. So 0 at Y is the top and 2000 is the bottom. So let's go ahead and write this, and let's see what that changed. So let's go here, and let's do... Oh, wait, I didn't fix the underlying problem. 1 second. Let's bring this back over here. Okay, what am I doing? J is animation.currentFrame. This should work. Should be fine. So let's go ahead and make it one more time. And unused variable J. Wait, that's not unused. What was your warning? Unused variable J. Oh, that one is unused. Yep, they were right about that one. We're not using the color white. That's fine. We will remove the color white in just a second. And give it a second to do its thing. In fact, we could make this tree look really tree-like by coloring it brown instead of blue. Anyway, let's see what the animation looks like. Mirage animation.gif. I give it a second to do its thing. We're going to draw all of the points. Hey, Gothic Death Eater, what's up? Okay, this is almost looking okay. We have to move the numbers down a little bit, and then we'll be good. I'm kind of liking this. Okay, so let's go down and let's do it. Did someone say Vim? Death to Vim? Okay, you do whatever you want. So text box height divided by 2.0. Let's not divide this by 2.0. Let's just put it under text box height. Right, this go to Mirage in what? I don't know what I'm doing anymore. Let's make it. Okay, again, color white's not being used. That's the one thing that we have problems with. Okay, so once this creates a new animation, we should see all of the encoded strings being placed under the words that we want. Or under the, what am I saying? Under the letters. And we'll see what happens there. So again, I don't really like. I play along with some of the text editor wars, like the Vim versus Emacs one. I totally play along with that one. Okay, let me see what we got here. So we have all these being drawn, and let's see. This doesn't look awful. Okay, we have some problems which we can fix, but I think this genuinely looks better than it did before. This is way too advanced for me. Very cool though. Hey, Colin Kidiak. Thanks for coming in, man. Judging from the name, you want everything to die? Okay, so let's fix this one more time. What do we need to do? We now need to give it an offset based off of how big the circle is. Now, how did we decide how big the circle was? We decided how big the circle was based on a weight ratio. Let me go through and check that out one more time. Judging by your name, you've never read any popular books? Wait, what? Come on, guys, no fighting in chat. Okay, what are we gonna do? Let's go up to, not draw encoding. We are working on draw encoding. I want to do draw layers. Wait, what do I want to do? Draw tree, probably. Okay, so what do we have here? We have root weight. And then we have times 0.5, 10. Okay, good. So that's what we want. We want to read in root weight 2. Again, guys. Sorry, if, I don't know what happened, but if there is any type of argument, no arguments in chat. Okay, so let's do position origin. What I actually want to do is add in a double weight. And then we have position origin here. So let's go down here. Did someone say fight? No, fight. Okay, so what are we going to do? Drop text. Let's go up to the very top. Let's go down to main. I'm really liking how this is turning out, guys. I don't know if you guys are not, but I'm really liking it. So now we're going to say weight, double weight. Okay, position origin. We have a couple more things left to do, but it's turning out okay. Down to the bottom. Okay, so now how are we going to modify this? So let's change it to text.height divided by 2.0 plus double I. And then we're going to add an additional offset. And this offset is going to be equal to plus, and you're going to notice this from before, 10 plus weight Is that it? I think I did something stupid here. It's not 10 plus weight. It's 10 plus weight divided by something or multiplied by something. I think it's 10 plus weight divided by 2. Draw a tree. 10. Where are we? Grow circle. Yeah, times 0.5. Good. We'll go from there. So, what do we want? Drop text. 10 plus weight times 0.5. Write this. Now let's see what happens if we make it. It broke. Yeah. Drop text. That's because I failed to add in the root weight here. So we do drop text. Let's add in root pointing to weight. Good. Let's add in some stuff here. Thanks, calling Kidyak. Sorry about that. Let's right here, and let's make it one last time. Again, color white's not used. That's okay. Okay. Let's go from there. Oh, sorry. I need to quit doing that. Whenever I get kind of excited, I rub my hands together, and you can probably hear it in the microphone. In fact, I'm pretty sure you can. So I apologize for that. Nothing ever becomes perfect without it breaking. Yep. Story of everyone's life. Okay. So what's next? Once this is drawn, I think all of the numbers should be drawn in the appropriate location. And then from there, we can fix up the last thing we need to do, which is not, unfortunately, trivial. Mirage animation.gif. And this is what I was kind of dreading to do all day, but hopefully it won't be as bad as I think. Okay, we're actually going to have to give this a little bit more of an offset. So you'll see that these ones are cut off. We're going to have to give it just a little bit more of an offset. So let's say, instead of 0.5, let's multiply it by 0.75, just to give it a little bit of an extra position. Now let me think. Is this correct? Why are the ones being cut off? Oh, I bet you I know why. Times 0.5. Let's do this. Let's now try it. Make one more time. And we'll see what happens. Shekels? Oh, sorry. I need to quit. Like dry washing your hands. Does no one ever do that? I do that all the time. And maybe it's because I'm just a little bit, I feel like I'm actually a little bit OCD in certain things. Like, not like, I don't know. I feel like I am. I have some weird tendencies. But, like, it's obviously nothing I'd go in about. It's just, random things. Like, every time I lock the door, I have to try to open the door in a very weird pattern. So that I remember that the door is locked later on in the day, and the pattern has to be different than, yeah, this thing. Does no one ever do this? That's called dry washing, isn't it? Okay, good. So those numbers are in the appropriate location that we want them to be in. I'm going to give them another pixel or two distance. So instead of 10, I'm going to give them... Careful with your language. Again, we want to keep it family friendly, but yeah, I totally get what you're saying. I've got quite a few friends who definitely, yeah. Anyway, let's go ahead and make it. But yeah, so I've got a whole bunch of weird tendencies there that I do. So like, what am I saying? Dude? What are you saying dude for? Mad Dave? Okay, 1 second, almost done there. Give it a second to do its thing. I cringe whenever I see my dead skin. Oh, really? I'll be honest, I swim a lot, and I also I'm in the water a lot, so I don't typically see my own dead skin in a way. I don't know. Okay, so let's see, what do we have here? Good, this looks fantastic. I really like this. Okay, so now the part that I was dreading, and maybe some of you see why I'm dreading it. Maybe some of you guys don't, but the last thing we need to do is increase the size, the Y resolution here. Okay? Now, the only problem with this is that this entire... I know I am. I know. This entire drawing was created in such a way that we used the resolution of the image. We filled the image, right? So like we said the image was 400 by 300, and then we said, okay, we're using this entire 300. Now we need to use 200 out of the 300, and this is going to be a little bit of a problem. Not so big of a problem, but a little bit of a problem. Okay, so let's go and just try this out. So what we need to do is every time we draw something in resolution Y, we can do this in a number of ways. The way I think is easiest is every time we draw something with resolution Y, we actually scale that resolution of Y. So we put it in like resolution of y times 0.75. So we have this little bit left. I think that should solve the problem, but I'm so just nervous about it. You know, I think it's gonna break, but that's fine. Okay, because we have, actually, I think I'm making a big deal out of nothing. I probably am. Okay, so grow circle, animate lines. We want draw tree. Here it is. When we give it an initial origin position here, we're giving it animation resolution y divided by 8.25, and I don't know why I divided by 8.25. What? Why did I divide it by 8.25? I have no idea. What did I do there? Root ori y is level times animation resolution y. What? What was I doing? Why 8.25? Let's change this. Let's change it to like 18. Raj, what was I doing? Why 8.25? Gosh darn it, this is why I should comment my code. Guys, lesson to you all, comment your code. Don't just go through and pretend you're gonna remember what you were doing with your life. You're never gonna remember what you were doing with your life. Okay, give it a second to make this animation. I think this should solve the problem actually, but I don't like the solution. So we're gonna have to fix that in a bit. Yet another person running outside. It's a good day to run, actually. Okay. Give this a second to do its thing, and then we'll see what we need to do from there. I don't know, guys. I don't know. Okay. Let's see what it looks like. Mirage animation.gif. We're drawing all the nodes. All the nodes are up a bit. So this will solve the problem. This actually did solve the problem. Now, you'll note a couple weird things here. I don't know if I necessarily like all the weird things, but that's okay. I wish your life was commented by Morgan Freeman. Okay, so this did solve the issue. I don't like the result. So let's go and make this a square, just because I like squares. And in fact, let's keep this at 8.5, and let's scale this here by a bit. So we're going to multiply resolution y. I don't know what I was doing. Why 8.25? Was that just a random number? How did I come up with 8.25? Real quickly, let me try something. What happens if I just divide this by 8.00? Make... What was I doing? That'd actually be really good. You could imagine, you could probably make a movie out of that. The Commenter. Like, that's the name of the movie, and it's just some guy going around just commenting on other people's lives. Okay. I'm not... Why did I choose 8? Huh. Not sure. Oh, I know why I chose 8. Oh, shoot. Darn. Okay, I know why I chose 8. I know exactly why I chose 8. Int level. Okay, so in draw tree, we're actually going to read in one final number here, which is going to be the max level of the tree. So let me go here. We have int alphabet size, int max level. Let's go down here and change this to max level. Okay. And actually, let's go to every time we do draw a tree. Okay, draw tree, draw tree. Let's add in max level of, and I'm just gonna set it to 8. We can read it in just a second. Regenerate key nodes, draw internal, final tree. Where else do I draw trees? Here. Int max level. Any other place that I draw trees? Let's see. Draw tree, draw tree, draw tree. Max level. Of course, it's recursive. Max level. Okay, anywhere else? Draw tree. I think I updated everything else. Okay, so let's write this. Go here and let's make it one more time. And we'll give it a second. I haven't been able to stop dry washing my hands. I'm sorry. I really apologize. Okay. I would make for a pretty hilarious movie. I think it'd be a fun movie. Okay. So, it's a good day. So we've got about 30 minutes left in today's stream, so hopefully we can get everything done on time. I think we can. I think we've got enough stuff done today. And actually, I'm really happy with how this turned out. Like, Man, this is awesome. Like, I'm excited. We're making I'm going to put this on YouTube in a bit, like in a few weeks. Let's see. Okay. So that's why I did 8.25. I added a little bit of an offset because otherwise these points at the bottom are, yeah, that totally makes sense. Okay. I get it now. Let me scroll down a little bit. Yeah. I get it now. Okay. So what are we doing here? Y is going to be level times animation resolution Y, but I think actually I can add a bit of an offset here. Let me think. So if we do, what am I thinking here? Let me open up one of these images in GIMP. So let me run the last GIMP. And let's see, we have some extra space up here. So why don't we just shift it up a little bit? Shift this entire guy up a little bit. I don't understand why we have so much empty space at the top, but we certainly have a lot of empty space up there. So this is gonna be 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So it's the bottom of the screen. 1/8. Oh, why don't we just do it this way? Divided by 8, but instead we do, where are we? What am I doing? Draw tree. Level -1. Let's do level -1. Now let's do make. And this should solve some of our problems. Not all of them, but some of them. And then all we need to do is scale it by a very small amount, and we will be set. Hopefully. Yeah, that should work. Okay, let's see. What else should I say? Generally, I'm not very good at coming up with stories while streaming, but this stream has a lot of dead time where we're just kind of waiting for like images to be made and stuff like that. So, yeah. We'll just look at the image. MirageAnimation.gif, and let's see what it looks like. Here are all the dots. They're being created in the appropriate location. Let's see how far off the text is cut at the bottom. It's actually not cut off by that much. I mean, a little bit, obviously, but not that much. So let's see, how do we want to scale it? I guess what we should do, let me take a look at that very top line. 1 second. Okay, the very top line is being cut off by just a small amount. So what I'm going to do is add a little bit to this. So let's add in here. And you guys are going to hate this. I know you're going to hate this, but that's okay. We're going to add in 5 just to drop it down a little bit. And then we're going to multiply this animation resolution Y by a variable amount. And this amount is going to be, depending on the max level, where you could reserve space for the longest bit string at the bottom. Yeah, that's exactly what I'm doing here. So the idea is that we're going across the entire animation resolution Y. They're going along this entire resolution Y. So what I want to do is I want to pop it up a little bit. So I don't know how much I want to pop it up by. That's the question. How much space should I reserve? And the amount of space that I should reserve should be dependent on the max level that we go to, right? Because the bigger the max level, the more space we're going to need. So let me think. If we have a max level of 8, that means we have 8 characters, right? At the very bottom. Here, I'll show you what I mean. So we go to mirageimage.gif. We could calculate the height of the text. Yeah, that's totally fair. Let me think. Animation resolution Y. Oh, yeah, that's totally fair enough. That's a great idea. Yeah, that's a fantastic idea. Minus. Let's do max level. Times 10. There's some extra spaces in here that I can get rid of. Write this, go over here. And let's do make. Give it a second to make. Hey, inventor of stuff, what's up? Okay, so once this is made, we're going to take a quick look at it. Gosh darn it, what am I saying? Once it's made, we're going to take a look at it, but I think this solves the problem. Thanks a lot, Zadiston. That was totally what I needed. I don't know why I didn't think of that. I was just going to scale it, but now we have scaled it. Just linearly instead of multiplicatively. the sky. I haven't heard that one in a while. Okay. 1 second. Converting. Good. Let's take a look at the animation. Okay, so here we're drawing all the dots. Looks good to me. Drawing all the lines, creating our Huffman tree, going back down, drawing all the numbers, and bam, look at that. They are all being drawn appropriately. Good. I think that looks fantastic. I really do. I like this. I think it looks great. So we could read in a number of different things here. That's fine. Right now I'm going to comment the code and do some things. So I need to do some code cleanup. Just because it right now looks kind of ugly. Good. I really like this, guys. And I actually like keeping it blue, too. I was debating turning it back to white, but I think keeping it blue gives you a visual indicator of what has and has not been encoded. So what I want to do, just to check, I want to scroll down, go to the very end tree right here, and let me just, yeah, if you see this from a distance, I think it looks pretty good. I'm quite happy with that. Okay, so let's go over here, and let's see what we need to do from there. Okay, so let's do code cleanup. That's what we need to do. We need to do a lot of it. So first, let me find all the color white, because we don't use those anymore. So let's go ahead and get rid of this guy. Let's change this to, instead of color blue, let's just call it, I guess color blue is fine, but let's change it to color encoding. It's fine, that'll do. So we'll go down here, change all the color encodings, or color blues. So that's done very easily in Vim. It's just the following command. Whatever this is, %s. Yeah, well, if I could get a PhD for drawing pretty pictures, I would, I'd totally take that in a heartbeat. Okay, so now we're going to do color blue with color encoding. S. Yeah, the color struct has nothing but RGB. That's all it has. And I just screwed up. Sorry about that. Let me do S, color, blue, color. I keep misspelling blue. Blue, color, what do we want? Encoding. S. What? I could. We can do that. Well, kind of. I didn't initialize it that way. Let me think. You can just color encoding. Well, here, let me see. Does that actually work? Let's go here. 0.3. 0.3. 1.0. 1 second. Remove this. Now let me see if I can finally spell blue right. S C L R B L U E C L R encoding. S. Extra characters at the end of substitute. What are you saying? Oh, that's because it's G. Holy crap. I'm sorry, guys. I'm not thinking. BLUE CLR encoding G for global. There we go. It's fixed. Write this. Go over here. Remove this. Let's make it. 1 second. Okay. Sure. That works. Good. So again, I'm actually not savvy on all the C++ 11 features. Every once in a while, a new one pops up, and I'm like, oh, well, of course, that was obvious. I've done this before, but yeah. Every once in a while, I just completely forget what I'm doing with my life. Okay. So, draw encoding. Here's what we're going to do. Color of visual encoding line. Root right. Let's see, animate line. That seems fine. Root left. Animate line. Also seems fine and self-explanatory. Stop apologizing. None of us are offended. I'm gonna cut you every time you apologize needlessly. Mean face. Ah. Sorry about that. I don't know. I always apologize for everything. Like I'm like Canadian or something. Though for C++ 98, it's probably possible to do color. Yeah. It probably. I'm not sure. Okay, so here's what we're gonna do. Continually draw lines. I think he means cut audio. Draw blue lines to leaf node. And then here, if on leaf node, one second, if on leaf node, what am I going to say? Drop encoding string. Good. Okay, so we have drop text. This, I think, is pretty self-explanatory, but for the record, let's go through and comment some things in here too. So we're going to say, going through each... Oh, I didn't even think about knives, of all things. Anyway, so going through each, what do I want here? Code word. Letter in code word. And then going through each frame. Frame in layer. Okay, now what do we want? Source RGB, that's fine. Setting text to white. The one thing I do need to comment in is this height down here. Down here. Y height. Y height is, let's see, text width. Let's see. Location minus text width. Oh, text height. Minus font size. Times I. Oh, font size is 15? I'm not commenting on code. Well, good. Then what am I doing? This is weight times 0.05. What was that? Oh, then subtracting out size of leaf. Good. Just making sure I have this written down. Good. Oh, and then we also have plus arbitrary 2 pixel offset. Now there is a way to do this easier. There's definitely a way to do this easier. For now, I'm just going to leave it as this, and we'll worry about it in a bit. Okay, so drop text. Now, the next thing we can do to kind of fix things up, let me think. Let's go through and we've got a couple minutes left. So let's go ahead and add ampersands everywhere we need to add ampersands. This was mentioned earlier by Zadistin, sorry about that, and that's something we should probably fix. So create background, animation RGB, that's fine. Double time, position Ori. So every time we see position Ori, let's add in an ampersand there. Double weight, just fine. Int start frame, double time, position Ori 1 and Ori 2. Here and there. Double time, Huffman tree, definitely need an ampersand there. Next, node queue regenerated nodes, add one there. Final tree, good. Down here, node root, unordered map, bitmap. Keep going. Draw layer, SD vector layer. Yep. Let's see, node root. I'm going to leave that one as is, but everything else I will fix. So what do we want? Int level, alphabet size, int max level, that's fine. Bitmap needs to be changed. 1 second. And code word, let's go here. And change position Ori there. Okay, so now let's go down to all the functions and let's update them. And then we're going to run it one more time just to make sure it all works. So we have init, we have create background, draw frames, everything's fine there. Could you place the count in every character on every leaf after the encoding string? What do we want? We want to place the count in every character on every leaf after the encoding string. Wait, I'm actually confused as to what you mean. Could you place the count in every character on every leaf after encoded string? So do you mean we have a string, like we write a string up here, we do the encoding? Don't forget the member functions of frame. Yeah, we don't have too many, we just have init. But let me see, what do we have with frame? Sure, create frame. I think it's just PNG name here. Okay, so let me go down to create frame. Next, create frame, PNG name. Okay, position Ori. Let's go ahead and fix all these guys up. Patrick OMG, if you could explain a little bit further. I'm not sure exactly what you mean. Sorry about that. Double time, double radius. Let's keep going down. Kind of quick overview of the code that we've written so far. Animate line, start frame, double time. These guys. There. There. And here. Let me go up to the top again because I think I failed to do something. Grow a circle. Position 1, position 2. Wait a minute. Animate line, I think, has an additional argument. That's embarrassing. Animate line. There is indeed an additional argument that I have failed to put in. Alright. Line color, color encoding. Here we are. Wait, what? I'm a little bit confused here. Animate line. Animate line. 1 second. Go to the top. Yeah, okay. Somehow I've failed to put in color. My bad. Okay, so now we go down to the next animate line. How many times the character is represented in the text? Wait, let me see. Patrick OMG, could you place in the count? Oh, I see. So you want it to be like A10 or space 20. I see what you're saying. Yeah, so you want the number of times in here. We have changed the color and size based on that number, but that's something that we can add in relatively easily. So let's do that after I finish this, and we'll see what it looks like. Yeah, we'll see what it looks like. Okay, so animate line. What do we want? Let's keep going down. Draw internal. Huffman tree, final tree. No cube regenerated nodes. Yeah, I totally see what you mean now. I think the compiler just assumed that you were overloading the function and didn't complain. Yeah, probably. Okay, final tree. What's next? Regenerate nodes, animation node root, character bitmap. There. Next, draw tree. Let's see, count node int, generate nodes, alphabet size, max level. All that seems fine to me. Draw layers, vector layer. Okay, one more thing. Draw encoding, bitmap. And last but not least, drop text, position Ori. Okay, well, let's write this. Let's make sure it makes. I've got a feeling I missed something, but that's okay. Yes, I totally did. Invalid initialization of a non-constant reference, 99. Layer, create frame, frames, image. Oh. I'm going to change this back to no ampersand. Create frame. It's for convenience, but that's okay. Okay. Make. This one should make just fine, and let's check the image at the end. Okay. For declarations like those aren't really necessary if the order of your function definitions doesn't require it. It's okay. It's better practice, I think, to have it in there. So that's probably pretty good to do. Okay, so we added in a few comments here and there. We added in those ampersands. Let's see if we can add in the weight now. I'm trying to think of the best place to put the weight. I don't know if I necessarily want it in the circle, but once we have the animation up, we'll talk about where we want the weight to go. So let's do mirage animation.gif. Give it a second. All the dots are being created. Good. Everything seems fine. Okay. So now the question is, how do we put the weight in there? The problem is, I want the letters inside of the circles to be rather large, because this allows us to more easily see where each of the, like what each letter is. However, I do agree that the weight should probably be there somewhere. So let me think. If we put it inside of the circle, we don't have enough room. We have to like shrink the text size, which is fine. Let me get a quick sip of water. And let's see what we can do. Okay. So, yeah, it actually wasn't It wasn't at all intended. So there's actually 2 current bugs with the code, 2 things to look into. So let me go up to the top and let me remove these. So draw tree, nodes are being overwritten. That's no longer true. However, the nodes are being drawn backwards. This is something that I mentioned earlier, but I didn't bring up since then. The other thing is we need to find a way, find a way to, what do I want? Find a way to place weight number on each node. Check Y positions and draw a tree. That's fine. Okay, so here's what I mean. Let me go down to draw a tree. Okay, draw encoding will work. I say I'm going to the right first. However, I'm clearly not going to the right first. I'm clearly going to the left first. And that's, for some reason, the problem. I'm not sure why. I just got something mixed up, but I'm going left first when I want to go right. And I'm not sure why. So we got to fix that one up. In fact, that might be even more necessary. Okay, so this has to be in how we drew the points, right? Let me go up to where we drew the points. Draw a layer, draw a tree. Okay, if there isn't a right or there isn't a left, let's say we've gone right first, then we go left. Huh. Darn. If you swap the plus dx and minus dx in draw a tree. Let's see, where are we? Draw a tree, plus dx. Root or x, double count, alphabet size. That's not obvious at all what I was doing there, is it? Double count x plus 0.5. Double alphabet size animation plus animation resolution x. So let me think. What was I doing here? Yeah, the code's changed a bit. Here, let me go ahead and commit this version to GitHub. So let's do git commit Huffman visualization .cpp. Then we'll say, oh, oops. Git status dot. Yeah, so let me do git add Huffman visualization .cpp and Huffman .h. Okay, now we're doing git commit. And let's say added visualization of actual encoding. Not actual encoding, but creation of encoding strings. So we're going to do git push origin master. Now you should have access to the new code. And again, guys, we are almost done with the stream for the day. So if you're looking for this code, feel free to go to my channel, go to the info, scroll down to the very bottom, and click on this GitHub link right here. It'll bring you to Simuleos. Then you simply need to go to Huffman, and we have the code that we worked on today in under Huffman visualization and Huffman.h. Here, of course, the changes. We did a good bit today. I'm pretty excited about it. Now, about the drawing left and drawing right, that's something that we need to figure out. And quite frankly, I might be too shot to do it right now. So I might leave it for another day. Now, guys, it's up to you what we want to do tomorrow. On the one hand, I need to finish up visualization of this determinant video. So what I might want to do tomorrow is take a step back from the Huffman stuff, do the determinant visualization, which is another visualization that we're working on, and then come back to Huffman Tree on Friday. The determinant video visualization might actually not take the full day. It'll probably only take like a little bit of time here and there. So I'm expecting it to be maybe like half a day of the determinant and half a day of the Huffman Tree. I haven't really figured out the best way to do that one, but that's currently what I'm thinking about doing. So again, I wrote down the 2 things that we need to do on this visualization at the very top. So let's go Huffman.visualization.cpp. The 2 things we need to do is figure out why the nodes are being drawn backwards, and of course I misspelled being. That's perfectly fine. I misspell everything. And then we need to place the weight number on each node. So those are the 2 things we have left to do. Thanks, Patrick, for the suggestion, and Zadiston for pointing it out. Outside of that, guys, I'm actually probably going to end the stream right about now. So we've got a little bit of time left just to kind of say that's it for the day, but that's about it. So tomorrow, I think If you guys are okay with it, let me know if you're not okay with it. But if you guys are okay with it, I'm probably going to take tomorrow and finish up the determinant visualization so that I can go ahead and get started on that video, because quite frankly, I have a lot to do and I need to... I realize you guys are, you know, super pumped about the Huffman stuff, but that's okay. Let's keep working on the Huffman stuff, but kind of, you know, hit other things too. I need to kind of do some multitasking here. So that's kind of the idea. Good. Okay, so guys, that's going to be it for the day. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And I will see you around next time for the next episode of Simuleos, where we might need to negate all the X coordinates. I just need to think about it. It'll take like 2 seconds. But again, at the end of stream every day, I am completely shot. Like my brain just shuts down, you know? I can only do 2 hours of coding like this before I don't know, I get too tired. But guys, thanks so much for coming in. Tomorrow we'll work on the determinant visualization. Should be a lot of fun. A nice, simple thing to work on the side. And then we'll go ahead and get started on the Huffman tree after that. Hopefully we'll be able to start working on the dynamic Huffman trees, the Vitter algorithm, which allows us to create a Huffman tree kind of on the fly. That's going to be super fun. I'm looking forward to it. And this is another reason why we should definitely visualize the weight in some way, shape, or form, because the weights will be varying in that, that example. We can also find a way to draw internal nodes and things like that. This will come later. But at this point, I'm quite happy with how it looks so far. There's obviously still more to do, but hey, this is the first time I've ever really done visualization like this, and I think it's pretty cool. Anyway, that's it for the day, guys. Again, thanks so much for watching, and I will see you next time. Bye, guys.